Hi dear students. Today we are diving into the basics of how the Arduino understands our instructions. As I've told you already, Arduino is like a microcontroller, or you can tell a tiny brain that works based on the instructions we give for it. Just like humans communicate in English, we are going to communicate with the Arduino using a code. So there is an option called code present here. You can use any of these three: blocks, blocks plus text, or text. Text is one of the easiest ones, so I'm going to prefer text here. Try erasing this code first and try to type each and every line in the initial stages. And as you get used with the Arduino boards and with the project, you can edit the already existing code. I'm going to use a Word document so that it gives us a better understanding, and a better visualization. Let's start to write the code for it. So the aim here is to control a LED with Arduino. So in order to do this, we have some lines of instructions which we need to give to the Arduino. Don't get panic. All these are very simple and super cool. Okay, let's start with the first one. Int LED equal to 13. So what is the meaning of int LED is equal to 13? This is like, imagine you are giving a name to your LED, like calling it Mr. Blinky. Okay. We tell the Arduino that our LED is connected to pin number 13. Imagine you are connecting to 8th pin. So you have to write int LED is equal to 8. Okay, so this is how it works. Arduinos are case sensitive. The meaning is, as a human being, I know the difference between a lowercase and an uppercase A. But the Arduino board doesn't know. So you have to be very careful whenever you're giving the instructions. So here I used int. Int refers an integer here. So int should be in a lowercase and not in the uppercase. If you're going to give in the uppercase, your Arduino board will throw you errors. So you have to be careful about the lowercase and the uppercase letters, because your Arduino board is a tiny computer and it's not a human being. Okay, fine. So this is all about int LED 13. So it's like you're telling the Arduino our LED is connected to pin 13. Let's go with the second line. Void setup. As I've told you, Arduinos are case sensitive, and the brackets what you're using in an Arduino also you have to be very careful about. So whenever you're opening any curly bracket, you're supposed to close the curly bracket as well. So this is what we call it as a curly bracket. Now let's understand what is all about void setup. This is like setting up your room before a birthday party. It only happens once when the Arduino starts. So it's like a setup option where you are telling the Arduino what are the input and the output devices you have connected in your project. So here I'm using only an LED, right? So LED is an output device. As a human being, I know that LED is an output device, but your Arduino board doesn't know it. So inside this void setup, you are telling, hey Arduino, I'm going to use an LED and that LED is an output device. Okay, so this is what we are going to put inside the void setup. So inside the void setup, I'm going to use an instruction called pin mode, where M is supposed to be in capital letters. Okay, open the bracket, use the pin in which you have connected an LED, comma, output. Close the bracket followed by a semicolon. A semicolon is nothing but it is like you're telling the Arduino, with this the instruction is over, come on, go to the next line. Okay, so pin mode 13 comma output. Here we tell the Arduino that pin 13 is an output pin, which means we will use it to send signals to the LED. Okay, we are going to use a pin number 13 as the output pin because you're going to connect an LED to the 13th pin. So with this, my setup is over. So inside the void setup, you're going to merely tell the Arduino boards, what are the input and the output peripherals or devices you're going to use in your project. Next comes an interesting command, void loop. Void loop. So what does void loop represent? This is the main loop that it keeps repeating again and again, just like a song on repeat. Okay? Open the curly bracket and close the curly bracket. Now let's see what to write inside the void loop. Digital write. So there are two types of signals which are existing in real time. One is analog, another one is digital. Digital means yes or no, on, off. Okay, only two work it is going to do. Either yes, you are going to turn on the LED, or off, turn off the LED. So only two different work it's going to do, right? So I'm going to use a digital write here. We also have an option called analog write. So whenever you're working on the analog signals, I need to use that particular command called analog write. But right now my work is just to do the digital operation. So I'm writing digital write 13 comma high. Don't forget the semicolon. Okay. So what is the meaning of digital write 13 comma high? We tell the Arduino, hey, turn on the LED by sending high to the pin number 13. So you are sending the signal called high to pin number 13. It's like you're telling an Arduino, come on Arduino, turn on the LED. Okay. So high is nothing but it's like sending a 5-volt supply. Now your LED is turned on. What is your next step? I need to give a delay. Only when there exists a delay, I'll be able to visualize the on and off of an LED. So now it's time to give a delay. Delay 1000. So this makes the Arduino pause for 1 second. So whatever you are writing inside the bracket, it is taken as milliseconds. So the meaning here is it is 1000 milliseconds, means it is 1 second. So the meaning of delay 1000 milliseconds is this makes an Arduino pause for 1 second before doing the next step. Without this, the LED would blink too fast for us to visualize. So we have to see the on and off of an LED. That's the reason why I'm giving a delay 1000 here. What is my next step? I have turned on my LED. Now it's time to turn off the LED. So let's turn off the LED. So digital write 13 comma low. So what's the meaning of digital write 13 comma low? We now tell the Arduino turn off the LED. Okay. So low means turning off. High means you're making the Arduino in order to help the LED to turn on. That's the difference between high and low. And you have only two signals here, on and off. That's the reason why I use digital write. Okay. Then again, I'm giving a delay of 1000 milliseconds. That's it. We have done with the code. Let's paste this code in our Tinkercad. I'm copying this code and I'm going to paste it over here. Okay. Let's recollect what we have learned. Int LED is equal to 13. I told you an example. Imagine you are giving a name to your LED like calling it as Mr. Blinky. Okay. So we tell the Arduino that our LED is connected to pin number 13. Void setup. As I have mentioned already, this is just like setting our room before a party. Pin mode 13, output. Here we tell the Arduino that pin 13 is an output pin, which means we will use it to send signals to the LED. Void loop. This is the main loop that's going to repeat again and again. Digital write 13, high. Your LED is going to get turned on. Delay 1000 means that there's going to be a delay of 1 second. Digital write 13, low. The LED is going to get turned off. Again, there's going to be a delay of 1 second. So with this, your code is done. Now it's time to visualize the output. You can just go and click here, Start Simulation. Once you click Start Simulation, you can see the LED which is present on the Arduino board will turn on, indicating that this particular program is dumped inside the Arduino board. And you can visualize the LED gets turned on and turned off with a delay of 1 second. This is going to be an infinite loop because, as I mentioned already, the while loop is going to run infinite times. Okay? Unless you're going to stop the simulation, this is going to run. So in today's class, we have seen how to program the Arduino board. We will look into more complex projects in the upcoming videos.